Today, you will use the distributive property to combine like terms and create equivalent equations, expressions. This is where we're headed, okay? It's all about the distributive property, though. Has anybody got the first one done in their head? Has anybody solved 4 times 29 in your head, Braden?
116.
He says 116. Do you guys agree with him?
Yep. Yeah.
What about number 2? What do you get for number 2, Roper? You are absolutely correct. Did you do it all in your head? Okay. What about number 3? Number 3, Chloe.
364.
Do you agree with her?
Yeah.
I don't think I agree with that. What about number 4? Number 4. What do you get with number 4, Esri?
114.
114. What do you get with number 5? Number 5. 240. And number 6. Kaylee? 536. All right, here's my question. How did you do number 1? Somebody tell me, if you did number 1 in your head, how did you get 116? Jordan? Okay, so you did all the carry stuff.
Yeah.
Okay. Anybody do number 1 differently other than multiplying it the traditional way? You did it different in your head, Braden?
Like on 29, when I carried it, whatever hit it, I added that and put it in front of the 6.
Okay, so you did some carrying in your head. What did you do, Esri?
I broke up the 29 to 20 and 9, and then I multiplied them separately and added them.
So you said 4 times 20 is 80, and 4 times 9 is 36, and then added those two numbers together. That is a perfect example of the distributive property. You use distributive property. Okay? What about number 2? How did you calculate number 2? How would you break that up, maybe? What do you think there, Miss Jaslyn?
Break the 42 up into
40 and 2, which would,
and then you multiply 3 times 40, which would be 120.
Yep.
3 times 2 is 6.
so you got 120 plus 6, or 126. This one, 7 times 50 should be 350, right?
Yep.
And 7 times 2 is 14. 350 plus 14 is 364. Okay? Do you see what we're doing to do mental math? This one here would have been 6 times 10 plus 6 times 9. We're gonna, well, that's the distributive property, okay? That's all I want you to know at this moment. Sometimes you're already using it, but you just didn't have a name for it. Just like when we did the last section, you already used commutative property to put like terms together so that you could add them. You just didn't know what property. You didn't identify the property, okay? So we're going to be taking what we know and putting a name to it. That's all it is, okay? That being said, this is what the distributive property is. The distributive property is to multiply a sum or a difference. It's going to be an addition statement or a subtraction statement. You multiply each number in that sum or difference by the number that's on the outside of the parentheses. You don't solve what's inside the parentheses first. Okay? You take whatever's on the outside and you multiply it by each piece within the parentheses. Okay? That's distributive property. Here's what I see a lot of kiddos do, and I call it this way. I say, I don't show mine going under there. If I just wanted to show, like show my work, I do it this way. 3 times 7 is 21, and 3 times 2 is 6, and all together you get 27. That's how I show mine. That's just the way I've done it for years. I don't have to rewrite it this way. The problem I find with a lot of kids, though, is that they do what you will say, or many will say, is 3 times 7 is 21 plus 2. Because they forget that they're multiplying both pieces of that by the 3. And I think of it this way. How many of you like cake? Do you like chocolate cake or strawberry cake or German chocolate? Okay? And have you seen those decker cakes? You know, those double and triple decker cakes? Okay? That's, as to me, I see it this way. I've got one cake here. My cake's not very round. That's a terrible cake. That's bad. I don't like that. What if I go this way and say, well, give me. All right. Here's one cake. Here's another cake. Okay? Now, when those 2 cakes are put together, I want frosting on the whole thing. You guys like the frosting? Yeah. Well, to me, what's outside those parentheses is my frosting. That's the frosting. And I'm going to frost this layer, and then I'm going to put this one on top of it and frost that layer. And if you've ever had a double-decker cake, that frosting in the middle, oh man, it can make it the best.
You're making me hungry.
Okay? Distributive property is like frosting a double-decker cake. You got to frost both pieces of what is inside the parentheses, okay? That's distributive property, all about the frosting. So, use distributive property and mental math to figure out 8 times 53. Evidently, I still got. Oh, I can't. It's okay. So, if I'm going to use distributive property, somebody tell me, what am I going to multiply and then add together? What would I multiply? How am I going to break it up? 8 times 50 plus 8 times 3. Okay? And if I'm doing it in my head, well, 8 times 50, what's 8 times 5? What's 8 times 5, Ben? 40, plus I need another 0, right? So that's 400. And 8 times 3 is what, Josie? 24, and 400 plus 24 equals 424. Okay? That's not too hard, is it? Just thinking of the pieces. Okay? Now, this one here says distributive property again. I've got to plug my computer in. Somebody tell me, how are you going to break that one up so that you could use that distributive property? How would you break it up? Tyler, how would you break it up?
You take the 2 and put it off to the side, and then multiply 1/2 times 3/4.
Gotta have the 1/2 times the 2 plus, because this is 2 plus 3/4, right? 1/2 times 3/4. And when you put them together, you get the full answer. Mr. Chance?
Are you recording this?
Mm-hmm. Okay. So what's 1/2 of 2? Yeah, what's half of 2? 1. What's half of 3/4? Or 1/2 times 3/4, Cashton? When you multiply these together, what do you get? 3 what?
Yeah, 3/8.
3/8, good. So 1 3/8 would be my final answer. Okay? Can you do that in your head? 1/2 times 2 is, half of 2 is 1. Half of 3/4 is 3/8, and you add them together, 1 3/8. Do you agree that 2 3/4, do I have equivalent expressions? Is that an equivalent expression? Okay. And if I multiply 1/2 by both pieces, I get 1 3/8. Do you agree? Altogether. Does it make sense to you now? It is easy. Okay, well here's a question. I'm not using mental math. I'm going to write, now we said we're going to use the distributive property to combine like terms and create equivalent expressions, okay? So I've got this expression, 5 times 41. And I'm going to tell you, I think it's going to be equal to 5 times 5 times 40 plus 1. I think I can do that math, and they're going to equal this. These are equivalent expressions. That's what I believe. Okay? So somebody use your calculator and multiply 5 times 41. 205. Okay? 5 times 40 is 200, isn't it? And 5 times 1 is 5. Does it check? Are these equivalent expressions? Yeah. And I use the distributive property to find the product of two expressions. I've created equivalent expressions by breaking it out. Okay? That's kind of what we were doing, identifying those equivalent expressions with our commutative property and our associative property. Same thing. It's still an equivalent expression. Okay? What about number 4? What is it going to look like? What's the equivalent expression going to look like? Somebody tell me what that expression should look like. Kaylee?
2/3 times 1, and then 2/3 times 1.
Running out of room. I wonder if I can do this. I want to move you. Okay. And I want to move you. Ruh-roh. I don't think I want to do that. I need to. Let me see if I can. It won't let me. It won't let me take that one out of there. Can't get out of there. Okay, I'll just move it down like that. Good enough. Okay, so, and then we said that's 1/2?
Yeah.
Okay, Are those two equivalent expressions? Are you sure? Well, let's find out. Do I ever multiply mixed numbers like that? So this one is actually 2/3 times 4/2. Am I correct? Bow tie. These two cancel. Do we agree? So I have 4/3. Agree? Okay. What is 2/3 times 1? What is 2/3 times 1? 2/3. How do you know that? What property?
Multiplicative of 1.
You've mixed up two of them. Multiplicative identity or the multiplication property of 1. Good job, Chloe. Okay, so, and then what is 2/3 times 1/2? 2/6. Okay. 2/6, which is, 2/6 plus 2/3 would be 4/6, wouldn't it? 2/3 is 4/6.
Yeah.
Okay. Oh, ruh-roh. This is 2/3 plus 2/6. Okay. How does 2/3 simplify? Or 2/6 simplifies down to what? Why is it 4/6? Yeah. Why is it 4/6? 2/3 turns into 4/6. Something's wrong here.
Yeah, it's 3/2.
Ah, that's what's wrong. Mrs. Rakestraw. That should be 3/2, shouldn't it? You guys got to catch me.
We were raising our hand back here.
Okay, so this should have been 3/6, right? Yeah, there we go. And this simplifies down to 1/3,
The 3 and the 3 cancel each other out.
correct?
No. Because the 3 and the 3 cancel each other out.
Oh, yeah. All right, let's redo that one. This is Rakestraw's. This cancels 1, this cancels 1. So that gives me a whole 1, right?
Yes.
And does 1 equal, this was 2/6, and I've got plus 2/3, which is the same thing as 4/6, am I correct? And 4/6 plus 2/6 equals 6/6 or 1, and it checks, right? Okay. Fractions makes it a little bit tougher, doesn't it? Okay. We can get messed up on them pretty quick and easy. What about, I'm going to give myself some more room up here because that number 2, what was number 2?
9 times 19.
9 times 19? Okay. So what's it going to look like with the distributive property? What's it going to look like with the distributive property, Josie?
9 times 10 and 9 times 9, and then we add them.
Good. So I have 90 plus 81. And when you add those two together, you get 171. And when you use your calculator and you multiply 19 times 9, do you get 171? Okay?
Yep.
You know at that point you're correct. It checks. The two expressions are equivalent. Okay? Move on. Let's see. Okay? Now I'm going to use the distributive property to simplify this expression. Can I get a final answer? No, because I don't have an equal statement, do I? So, if I distribute 4 parentheses n plus 5, if I break it up, I'm saying 4 times n plus 4 times 5. Okay? So what do I get whenever I finish it up? What do I get? What is 4 times n, Cole? What's 4 times n? Just 4n.
It's 4 and plus. Then you add 4.
4 times 5 is
40 or 20.
20, good. Can I go any farther than that? Have I combined my like terms? These two are alike, I can combine them. I can't combine this 4 there because this 4 is attached to the end. It can't be taken apart, okay? So you do number 12. Use the distributive property and tell me what the simplified expression would be. We're not on that page. Can you go to the same page we are? Good, you're gonna get there. Now wait a minute, maybe, yep. What do you? Check your shoulder partner. Just keep the line with it. So it's 2 wide. Keep the line, it has to say that, okay? And then it's gonna be plus. What are you gonna do next? Or minus, because it says it's minus. Well, what's outside here that you gotta do to that 3? What do we do up here to this, to the 5 that was in here, we had to do what?
We have to subtract that from 12.
Didn't we have to multiply the 4 times both pieces? You gotta multiply the 12 times both pieces. You gotta cross both pieces of that cake. So your subtraction symbol stays the same. But then your next expression is 12 times 3. And then you simplify from there. Okay, now simplify. You're right, that expression there is correct. As I walk around, what I should be seeing to start with is 12 times 2y minus 12 times 3. And then I gotta simplify it. And 12 times 2y is gonna give me what? Chance?
24y.
I got 24y minus 12 times 3. And 12 times 3 is what, Ben?
36.
36. And that's it. That's where I stop, right there. I didn't like my y. Well, it's not. Done with that. Okay? Do you see how we frosted both of the pieces of the cake? Okay? We had to take the 12 and multiply it by everything that's inside the parentheses. Multiply the factor outside of the parentheses by everything inside. So if that's so, how do I rewrite this so that I know what I'm going to do? Looking at C, how do I rewrite C so that I know what I got to do? Chloe?
9 times 6 plus 9 times 2.
What about that letter there in the middle?
Not it. By 9.
I can't throw X away. Is this, remember how you used to write numbers in expanded form? That's what we're doing. We're expanding that multiplication expression. That's what we're doing. Using the distributive property. So what is 9 times 6?
54.
54. What do I put for 9 times x?
9x.
Okay. What's 9 times 2?
18.
Can I do anything else there? Can I do anything else to this one? Because it said I had to simplify. What do I need to do, Ben?
54 plus 18.
I need to add the 54 and the 18 because they're like terms. And the commutative property would let me put them together. And so if I use the commutative property, and I said, well, commutative property, I'm going to say 9x plus 54 plus 18. What do you get when you add those two together?
72.
Plus 72. Can I go any farther? No. That's the only like terms I have. Okay? Ooh, there's a lot. Let me see. Let me see a math journal. We may stop there if I've given you enough. I don't want to give you too much that you're lost.
I'm already lost.
Yeah, I'm going to stop right there. You have just enough. Are you going to be successful? Let me see. I want you to do number 7. I want to make sure you have enough. I want you to do number 7 completely on your own. Good. You two check each other. Check with your partner. Okay, now look, looking at what we did. You have to multiply this times this plus this times this. Okay, is that an addition or a multiplication? It looks like addition. And you can't use the x anymore for multiplication, right? So you either have to use the dot or you have to, there you go. Yeah, and that's fine. Normally though, you wouldn't move the order in there, but you do. There's nothing wrong, okay? So 14 plus what? No, 14 plus what? Because see, these were added inside. So keep that simple. Really? What's 7 times 8? Look back on your notes and see what we've done on all those. Yes. Yes. The only thing is, whoa, no. What happens when you multiply these two together? Yeah, so this should be plus. Yes. Yes. Josie, what'd you get, babe? Oh, because you missed something. Let's look at it.
There's my second answer.
All right, here's what you should have written first. The equivalent expression. 7 times A plus 7 times 2. That's your equivalent expression. Okay? And 7 times A is 7A plus, what's 7 times 2?
14.
14. Why do I have an addition statement right there? Why do I have a plus right there? How do I know it's addition? Emmy?
Because in the original problem it said 7 times A plus 2.
Because of that one right there. I keep that one here, and I keep it here. Okay? And that's what I saw kiddos missing. They didn't know where to put the pluses or the minuses. All right? Okay? So, expand number 8. Expand that distributive property. What's it going to say? If I expand it, how do I write it? Jordan, how should I write it?
11.
Okay, go with the first one first. 3 times D. And then what?
Subtract.
Good. Do you know why you have to go with the first part of that first factor first? If I switch those 2 factors, would I get the same answer in a subtraction statement? So you gotta be real careful about that, okay? So what is 3 times D? 3D. Minus, what's 3 times 11? 33. Okay? Is number 9 going to be really hard? Is it different? A little bit, because it's got 3 parts. But how do I know? Is number 9 going to get you with this one and this one? Okay, so expand number 9 for me. Write it on your paper and have it expanded. Let's see if it gets you. Good, now finish it. You got it. You did exactly what you needed to. Now finish it. Times 2 plus. Okay, the only place I see where it got you is right there. What should that symbol right there be?
Minus.
So keep it there, okay? Otherwise, you got it. Good, Josie. Finish it now. Process looks good. You kept those 2 together. What are we supposed to do? We have to break them out, don't we? We broke it out here and here, didn't we? We gotta break that out too. Into 3 parts. And look, we took the 3 and we multiplied it by each of the pieces. You only multiplied the 7 by one of the 2 parts. Okay? Okay. What should this one look like? I'm gonna bring it down here because I can't show it there because there's not enough space. What should number 9 look like? Somebody tell me how to expand it. How am I gonna expand it, Chloe?
7 times 2 plus 7 times 6. Subtract.
Oops, oh good. Mrs. Rakestraw wrote the wrong number. Minus what?
7 times 40.
Good. That's exactly right. Now you just simplify. 7 times 2 is?
14.
7 times 6 is?
42.
And minus 7 times 4 is?
28.
And when you add 14 and 42, you get 56? Agree? Okay. The very back page as your assignment. Okay? I want you to try it. Now, your notes are your resource. If you, in doubt, look at what we've done. Okay? And it is time to go.
Are we doing math textbook part 2?
Page 39, yes, textbook TB, page 39.